All right, so imagine a hard-boiled egg that's lying on its side. That's not a very good hard-boiled egg, but I did the best that I can. All right, if I were to take vertical slices of this egg, like if I were to cut that egg and then kind of show you that slice, what shape would that slice be? A circle. Very good. Okay? All right, so the vertical slices would look like circles. All right, but if I had that same hard-boiled egg and I was taking horizontal slices like that, if I cut the egg in half and then held it up to you, then what shape would that be? Oval. Good. All right, so that's kind of, put that aside. Right now I need to find the formula for the area of several shapes, and this is just a review. If a square has a side of S, then what would the area of that square be? S squared. Very good. Okay, what about an equilateral triangle of side S? An equilateral triangle is a triangle where all three sides are the same. So imagine that all three of those sides are the same. S, S. Close, Nikki. The formula for the area of a triangle is 1/2 the base times the height. So the base in this case would be S, but the height would be √3/2. √3/2S. Very good. An equilateral triangle, all the angles are 60 degrees, right? And your altitude or height is going to hit this side at a 90-degree angle. And that's going to cut both of these triangles into 30-degree triangles. So you basically have the hypotenuse that has a side of S. Well, if the hypotenuse has a side of S, the side, and right now I'm just kind of dealing with half of the original triangle. What would this base be right here of this triangle? Right, S divided by 2, or 1/2 S. And then the side that's across from the 60 is the square root of 3 times the short leg. So √3 times 1/2 S would be √3/2 S. So the whole base of my equilateral triangle is S, and the height of my equilateral triangle is √3/2 S. So if I simplify that, the area of an equilateral triangle would be √3/4 S squared. So you either need to memorize that formula or know how to get that formula. All right, what would the area of a rectangle with length S and height H be? Shh. That was funny, whoever did that. SH. All right, an isosceles right triangle with leg S. For an isosceles right triangle, the two legs are going to be the same. So if one leg is S, the other leg also has to be S. So what would it be? 1/2 S squared, or S squared divided by 2. All right, and then a semicircle with a diameter of S. Pi S squared over 8. I came up with that very quickly. I'm very impressed. The formula for the area of a circle is what? Right, pi r squared. So the area of a semicircle would be 1/2 pi r squared. All right, well, if the diameter is S, then what's the radius? 1/2 S. But you've got to be careful here because you're taking 1/2 of S and squaring that whole quantity. So 1/2 S squared becomes S squared over 4, and then times the 1/2, because we're just talking about half a semicircle, would be 1/8, or pi over 8 S squared. Very good. All right, so you're going to need to know those 1, 2, 3, 4, 5 formulas of areas of shapes. All right, Emmanuel the duck has just bought land with the perimeter set by y equals negative x squared plus 2, x equals 0, and y equals root x. He lives in a math world. He plans to build a barn which uses the area described as a base. But the barn is going to be built up so that the cross sections perpendicular to the x-axis will be squares. Okay, try and visualize what that would look like. So his land is the shape of whatever the intersection of those graphs are. And then the barn is going to be built up so that its cross sections are squares. It's going to be a what? A very modern looking barn. Okay, if you haven't already, go ahead and draw his base on here. You should be able to do this without a calculator. If you need your calculator, that's okay. Negative x squared plus 2. It's going to be an upside down parabola. And the square root of x looks like that. And we also have x equals 0. All right, so his barn floor is going to have that shape right there. And then when he builds the barn, the cross sections perpendicular to the x-axis are going to be rectangles. So at this point right here, is the roof going to be really tall or really short? Tall, because since the cross sections are squares, did I just say rectangles? Okay, sorry. The cross sections are supposed to be squares. Basically, whatever the length of the square is, that's going to be the height of the square also. But right here is where all the mice are going to hang out because the roof is going to be really short. Because he wants to know if he's going to have enough volume in his barn to have a party with all his friends, and he needs a whole cubic mile of space to do that. So, yeah, okay. So, we'll see. All right, so the way that we're going to do this is the area of any rectangle, or sorry, of any square that the square cross section that I cut through his barn, the area of any square cross section would be s squared. But using these two lines, let's figure out what that area would be. What would the length or the side length of a rectangle, or sorry, I keep saying rectangle. What would the side length of a square be in this situation? Just the side length, the distance between here and here would be the top y, the difference of y values here, or the top curve minus the bottom curve. So in this case, s is going to equal negative x squared plus 2 minus root x. So therefore, the area of each of those cross sections would equal negative x squared plus 2 minus root x, the quantity squared. Okay, but I want to find the volume of this barn. So volume is basically length times width times height. Well, the square is basically taking care of my length and my height, if you will, like just the cross section of it. And then I would need to multiply by the width of each square. But that's what integration is. And if I were to integrate, so the width of each square is dx. So if I were to take an infinite number of squares and add them all up, then that would give me the total volume. So it's going to be the integral of negative x squared plus 2 minus root x, the quantity squared, dx. And what do you think I'm going to integrate from? 0 to 1. Okay, so that third dimension, that width of each of those squares, is where the dx comes in, and the integral And you could think of it as another Riemann sum of adding up an infinite number of rectangles, but as the width of those rectangles approaches 0, that's what integration is. Well, what you're really wanting to do is do a Riemann sum of all of those areas, but you want the number of rectangles to approach infinity and the width of each of those rectangles to approach 0, and that's what integration really is an infinite Riemann sum. So, I mean, back to when we were just finding the area between, you know, this graph and the x-axis. Okay. So, in case some else of you are wondering what Tamara was asking, back when we were just finding the area of this region between the curve and the x-axis, you could approximate it by using rectangles in a Riemann sum, or you can integrate the height times, basically integrate the height of each of those rectangles, because what integration does is it takes an infinite number of rectangles and makes the width 0. So basically I want to integrate this right here. For the sake of time, punch that into your calculator and let me know what you get. All right, so basically in general what you're going to do is you're going to take an area of the cross section, whatever that shape is, and you're going to integrate it between the 2 points. And that's what's going to give you this volume right here. So let's work some examples. We're going to find the volume of the solid whose base is bounded by those 2 equations and whose cross sections taken perpendicular to the x-axis are A, B, C, D, E, A, B, C, D, E. All right, so let's get this picture drawn. Y equals negative x squared plus 4. Upside down parabola. You're going to have y-intercepts at negative 2 and 2. If you need to graph it, that's fine. And then y equals Yes, this is not a multiple choice question. We're going to do one for all of these. But we're just going to set it up. I won't make you integrate it right now, because that's the easy part, is typing it into your calculator. Okay, and then y equals negative x minus 2. We have a y-intercept of negative 2 and a slope of negative 1. Okay, so the part that's bounded is my green region right here. And my cross sections are going to be taken perpendicular to the x-axis. Yep. All right, so the way that you do this is that you integrate the area of whatever figure you're talking about. So for A, and actually when you do this, my suggestion is always to figure out what S is. And S is always the length of the rectangle. So in terms of this problem, S, and it's always going to be top curve minus bottom curve for vertical rectangles. So S is going to equal what? Yeah, negative x squared plus 4 minus negative x minus 2, which, since you're going to write this a bunch of times, if you want to distribute that negative and combine like terms, you could. You get negative x squared plus x plus 6. All right, so if my cross sections are squares, then I'm going to integrate the area of a square, and the area of a square is just s squared. So negative x squared plus x plus 6, the quantity squared. And what are my limits of integration here? Smallest x to biggest x. Negative 2 to 3. Do you think those limits of integration are going to be the same for every one of these, A, B, C, D, and E? Yes, absolutely. If you're interested in going back and typing in these answers into your calculator, it's 625 divided by 6. Should you ever get a negative number for this? No. If you get a negative number, you've done something wrong.